I have a green binder and they used the wrong binder.
All right. Okay. So, the first half of Unity is all about chemical equations. And the second half of Unity is about something called the mole. That goes into the chapter 10 part. But for the first few objectives, we're going to be talking about chemical equations. Like I said in the do now, chemical equations follow the law of conservation of mass, okay? The number of atoms of each element before the reaction is the same as the number of atoms of each element after the reaction, okay? So just to orient you to chemical equations, this chemical equation, just put a bracket under the things before the arrow. We call these the reactants. Have you learned this before? Okay, the reactants are the things that you start with. Sometimes there's one reactant, sometimes there's two reactants, sometimes there's 3, 4. Usually it's like 1, 2, or 3. And then everything after the arrow is the products. This reaction only has one product, but there can be 2 products, 3 products, 4 products. Okay? And the arrow, the way we usually read the arrow is the word yields. Sorry, this is spelled wrong, isn't it? It should be Y-I-E, so I spelled yield wrong, I think. But in any case, don't say equals and don't say arrow, you say yields, okay? So if you were reading this, you would say 1N2 plus H2 yields 2NH3. Yields has 2 definitions. What does yields usually mean? Like give in, right? Yields usually means give in. So like the yield sign when you're trying to get on the interstate, you've got to give in to the other cars right of way. Or if one military army yields to another military army, they like give in. What's the other definition of yields? Like an output, yeah. So like if a farmer has a good crop yield, it means he produced a lot of crops that year. That's what it means in chemistry. It means produces, okay? So N2 plus H2 yields or produces 2NH3. The coefficients, as you know, are the numbers in front. Seems like we remember that. The subscripts, as you know, are the little numbers down low. All right, here's what I want you to do. This equation is not balanced as it is. This equation does not follow the law of conservation of mass, okay? The number of hydrogen atoms before the arrow and the number of hydrogen atoms after the arrow is not equal. The nitrogen atoms are equal. This has 2 nitrogens, but the hydrogens are not equal. I want you to figure out what coefficient you would put in that blank to make the hydrogens equal. Okay, you can make this coefficient whatever you want, but figure out what you would put in that blank to make the hydrogens before the arrow equal to the number of hydrogens after the arrow. You can even draw a little particle diagram if you want. On N2, right now we just have one. When there's nothing in the blank, you only have one of them. So you can draw a diagram if that helps. Figure out what you would put in that blank. Figure out what you would put in that blank.
Yeah, look at the top of it. Yeah, it like landed flat, and I heard it.
I threw my phone in Walmart and Target the other day. Not on purpose.
Figure out what you would put in that blank.
I
And you
forgot
can
it was on my
maybe
lap and I stood up.
I sat on my glasses. I just, when we were on fire class, I just flat out sat on them and forgot they were there.
all right.
I don't think. I feel like I remember that.
So you can see after the arrow we have 1, 2, 3, 4, 5, 6 hydrogens, but before the arrow we only have 2. So what would I put in this blank to get me up to 6 on this side? A 3. Because then if I have 3 molecules of H2, that gets me up to 6. A quicker way of doing it is 3 times 2 is 6, 2 times 3 is 6. 1 times 2 is 2, 2 times 1 is 2. When the nitrogen doesn't have a subscript, it's a 1. So remember, like we said in the do now, if you multiply the coefficient times the subscript, that tells you how many of each atom you have. Okay, so if you don't want to draw a picture, you can think of it this way. On this side, I have 1 times 2, which is 2 nitrogens, and I have, 2 nitrogens, and I have 3 times 2, which is 6 hydrogens. On this side, I have 2 times 1, which is 2 nitrogens, and 2 times 3, which is 6 hydrogens. These are equal, these are equal. So that's how we know the equation is what we call balanced. And to make an equation balanced, you can make the coefficients whatever you need to make them, as long as it's a whole number, okay? You can't change the subscripts, okay? But you can make the coefficients whatever you need to make everything balanced. And you can check that it's balanced either by counting up the atoms on either side, multiplying coefficient times subscript, or you can do it by drawing a picture, okay? Either way is good. You'll probably get to the point where you don't really need either one, and you can kind of make it balance in your head, okay? Sometimes balancing equations feels like Sudoku. Do you guys like Sudoku?
I hate that.
But you know that feeling where there's a lot of things in your mind that you got to keep in your mind at the same time? Mm-hmm. That's kind of how this is going to feel, okay? So for some people, it's going to feel very easy, and they'll finish the whole worksheet in 5 minutes. For some people, it's not going to feel that way, but you'll get there eventually. It's just kind of a weird type of brain exercise. All right, so balance the equations below by changing the coefficients. Okay, so this is the way that I do it. You don't have to do it my way, as long as you get the right answer. What I like to do is draw a line under the arrow to separate the reactants from the products. And then list the atoms in order, NaCl, F. And then on the product side, list the atoms in the same order again, NaCl, F. That makes it easier to see what's balanced and what's not. All right, so let's write down how many of each atom we have right now. As it is right now, with no coefficient, when there's no coefficient, it's a 1. Okay, so we just have 1 NaCl. So we have 1 Na, 1 Cl, and we have 2 Fs. And after the arrow, we have 1 Na, we have 1 F, so go down to F, and we have 2 Cls. So you can clearly see that this is not balanced. Okay, so I like to take the atoms the elements one at a time. NAs are balanced, we have 1 and 1. Are the CLs balanced? No, the CLs are not balanced. When an element is not balanced, go to the side that has the least and put something out front. Don't just change it down here, this is just scratch work. If you just say, oh, I'm gonna make this 2, no. You've gotta put something out front to get the chlorines up to 2. What should I put in the blank? By putting that in the blank, now I have 2 NaCls. So now I have 2 Cls, but what else changed? The NAs, so you also have to update your count of Na. The Na also changed. Okay, so now the Cls are balanced, which is great, but it threw off the NAs. Okay, that's going to happen. Okay, so all we got to do is go back up to the NAs, go to the side that has the least, and put something out front. What should I put in front of the Na? 2. Now I have 2 NAs, and what else changed with that? I also have 2 Fs. The Cl2 was not affected, okay? That has its own coefficient. The Cl2 was not affected. You can see by balancing the NAs, a lot of times this happens. By balancing one thing, sometimes you'll also balance everything, okay? So the Fs are also balanced. Now we're good, okay? So now this equation is what we call balanced. These blanks you can just leave blank, or you could put a 1. It's just no one usually writes a coefficient of 1, okay? Usually we just leave it as not having a coefficient. I just want you to notice that I didn't change any subscripts, okay? I didn't come over to the NaF and say, oh, I need 2 NAs, I'm going to make it Na2F. Does Na2F even exist? No, Na's 1 positive, F's 1 negative. You can't have Na2F. You don't make up your own subscripts, okay? Don't change the subscripts. You can't just make up your own compounds. If it says H2O, you can't just say, oh, I want it to be H2O2, and just change. No, you can't make up your own compounds that are fake. All you can change is the coefficients, all right? So if we go down to number 2, okay, we have K, Na, Br, K, Na, Br. All right. For K we have 1, for Na we have 1, for Br we have 1. Nice and easy. After the arrow, K is 1, Br is 1, Na is 1. Do we need to do anything? No, it's already balanced, okay? So if something's already balanced, you can just leave everything blank, it's fine, okay? One thing I want to emphasize is that I'm only grading what you put in the blanks. I'm only grading this. I'm only grading this. I'm not grading the scratch work, okay? Don't just make everything balance in the scratch work, but not fix it in the actual equation. You need to put it in the equation first, and then you can update your scratch work if you want. But this scratch work I don't grade. I just grade what's in the blanks, okay? So you take a stab at number 3, and feel free to move ahead. Just be sure you go in order, because they get progressively more difficult. Okay, feel free to move ahead, but be sure you go in order. Okay, so just take each one at a time and try to make it balanced. And if you get stuck on 4 or 5, I'm going to teach those up here as well, okay? Because 4 and 5 things get a little bit trickier. So there's certain, I want you to try it first on your own, but I will like explicitly explain how I approach ones like 4 and 5 as well. You can work on a class, no problem. Number 3 is right.
The next one. So, when I move to
Yep.
does that affect that?
Yeah.
So I'm just.
Perfect.
Multiply.
Multiply. Yeah. Right. So keep moving through. One of the O's are balanced. The G, you got the G.
Stuff, yeah.
So aim for, what's the number that 2 or 3 goes for? Good work. Oh, to get 4 hydrogen total, you'll need it. Good. So when you put that 2, that you updated that, what else did that affect? No. The 2 also affects the number of H. How many H's? So cross out. No, don't worry about that. First update your count. How many H's do you have now? Yes. Now go to the other side and put something there. No, you can still count them separately. You have 1 PB, 2 O's, 2 H's. Go back and fix number 4. So you got 5 and 6 right. All right. Good work on number 5. Yep. Okay, for this one, the other O's are not balanced.
Yeah.
So what would you put in front of there to get up to two O's?
2.
Mm-hmm. So I'm gonna put that in the blank. Good. Perfect. And what else changed with that two? And not just, it didn't just affect the O.
The hydrogen.
Yeah, so update that. How many hydrogens do you have now? Uh-huh. So now the O's are balanced, but H, go to the side with the least, put something out front.
Right.
Perfect. And everything's balanced now.
Okay.
Good. I'm gonna go over number 5.
So this is 3 and then that adds to the...
Yeah, it's a total 3. Things start to get real tough with number 7. Uh-huh.
So, also,
What do you got?
I thought people were just
Right, 'cause
so what
a 1.
what
Not a 1, because a 1 is basically what it has right now. There's nothing that you can do. Right.
do another one there?
Yeah, I can see how, like, there's nothing times 2 that would give me 3.
Okay.
So aim for the, what number do 2 and 3 both go? So aim to get 6 of those. I'm gonna go over that one now.
Like when we did that here, we tried to just...
Yeah, you can always do that. You can always go back and adjust. Number 5, yes. Yeah, these ones are right, and these ones, but you gotta just do all in. Yes, like you would a fraction. So it's okay to get the numbers too high, but always reduce them back down.
Second thing on the first. It's 3
7 is really confusing.
7, yeah, 7 is hard, but I'm gonna go over,
Y'all about to skip my name.
all right.
4, 5, and 3.
Pretty much all of you got 3, 4, and 5, but I'm gonna go over them anyway, just so you can see like my thought process for 3, 4, and 5, but you probably saw how they got progressively more difficult, but it seems like you figured it out. So keep working on, if you're done with 3, 4, and 5, just keep working, but I'm gonna go over them anyway. So for number 3, the NAs are balanced, the BRs are not, so I go to the side that has the least, and I put something out front. So by putting a 2 here, that'll knock my BRs up to 2, but that also affects the NAs. So the BRs are fixed, but the NAs got thrown off. That's okay. Go back up to the NA, go to the side that has the least, and put something out front. So I'm going to put a 2 out here. That'll knock the NAs up to 2, but that 2 also affects the Fs. This 2 does not affect this stuff over here. This has its own coefficient, which is right now a 1, because there's nothing in the blank. But so by fixing the NAs, we also fix the Fs. So the NAs are equal, BRs equal, CAs equal, Fs are equal. So we're good. So you can leave those blank, or you could put a 1 in the blank, but no one really does that. A blank not having a coefficient is the same thing as having a coefficient of 1. All right, number 4. Now we have 2 H's and 2 O's. On this side, we have 2 H's and 1 O. So the H's are balanced, the O's are not. Go to the side with the least, put a number in front. By putting that in front, this has a coefficient, a subscript of 1. 2 times 1, I now have 2 O's. But that also affected the H's. The H's now go up to 4. So the O's are balanced, the H's are not. Go to the side that has the least, put something in front. So to get this side up to 4, I would put a 2 here, because 2 times 2 will give me 4. 2 H2s, that's 4 H's. So 2 blank 2 or 2 1 2. And again, all I'm grading is what's in the blanks. I'm not grading the scratch work. If you don't need the scratch work, or if you'd rather draw pictures, particle diagrams instead of the numbers, whatever. All I'm grading is what's in the blank. Number 5. Okay, so you can see the first thing we do is balance the GAs. That's pretty easy. Okay. The second thing we need to do is balance the O's. This one's tricky. There's nothing times 2 that will give you 3. You're going to run into this issue a lot. It's what I call the 2-3 issue or the even-odd issue. There's nothing times 2 that will give you 3. So aim for the least common multiple. What's the least common multiple of 2 and 3? 6. The least common multiple is the lowest number they both go into. They both go into 6. Aim to get 6 O's on each side. 3 times 2 gives you 6. 2 times 3 gives you 6. The thing you need to remember is that this also affected the GAs. So the GAs are now no longer 2, they are now 4, but that's an easy fix. If you go back to this side, you can just erase this and change it to a 4. Okay? Sometimes you'll put in a coefficient that you need to change later. Again, this is not your, this stuff down here is just scratch work. It's not your answer. Okay? I don't care what this says. All I want is for this to be correct. All right? So in number 6, you run into that same issue of the, you run into that same issue, okay, where nothing times 2 is going to give you 5. So you got to aim for the least common multiple of 2 and 5. And then they get more and more difficult, as you guys can see. Once you're done, you can just work on work for other classes. I don't have anything else for you to do today. It's the type of thing that once you get it, it's like Sudoku. You kind of know that you've got it. But I can still come around and check your answers. But if you're done, you can feel free to work on work for other classes. You need help. Is number 8 the hardest?
I just don't do like the big
No,
numbers.
number 7 is the hardest.
7 was easy.
I just skipped over it. Where did the hydroxide go
That's
after?
balance.
It just like
But whenever you have coefficients like this,
I don't know, I looked at it and figured it out. And then I asked Alex if I got one number right, and then it was like, then I figured it out.
yeah, you'll see that it's balanced. So if you ever go
I got that
over
first
like
one
that,
really easy after that.
I'm avoiding a whole.
So I was like,
well, listen, I see hydroxide. I understand it's there, and then it's gone.
Yeah, I'm not really vibing with that.
so would it be like 3 H's?
Yeah.
I'd rather do my Sudoku. Or my nonogram where you put all the colors in the spot. Those are so peaceful.
No,
Just do that, watch some Netflix, like a great night. Have a snack.
I don't like this. This is too mathy.
Do you remember if that was 10?
It's multiplying. 2
yeah.
times 3. I believe in you.
No, but
That
then
seems
you're
to make sense,
multiplying
because that would
like.
be 2 times 2, 4.
I don't even know.
You got this, Reese. I believe in
I don't even.
I believe in you. Unless you don't believe in yourself.
Same thing with the sulfate.
You think it's like
Okay,
those
good
kind of
enough.
simple ones, and then I get to
I
the
like
complex ones like 8, 9, 11, 12, and I can't do them.
So I gather it's 3, 6, 6, 3, but significantly 6 is 1, So if you like go over or something, you can like reduce it. So
Yes.
I don't know how.
But PV is just 1.
I guess I made it too, I went too far, I guess, yeah.
I did one. I got number 10. Progress.
What, like, focus on the O's. Like, what would you put there to get the O's up?
And then if
And then
I
update your
thing,
No, these are. Wait, why did, whoa. This is just the O's on this side. How many O's are on this side? 3 and 8? What are these numbers? And then 2. Okay. And then on this side, how many O's are on this side?
Why does it make more sense when there's a lot more numbers?
No, because it just doesn't.
Yo, you're on this with the
Unless I don't have Twilight Tamatana.
How'd you get to number 7? I skipped number 7. I have all of them.
Yeah.
Yeah, okay, 7 and 8, 4, 6, 7, 8.
was so easy. I lost.
What is happening with this one? Number 7?
Shut up.
I'm doing
Yeah.
number to start with
No, I
that.
don't care. I'll do.
Should I just write the numbers?
Okay.
Like, I feel like I'm missing something. here.
Okay, how many PBs are in the form?
Let's see this.
1,
Shut up.
Oh.
2,
I got that.
2, no, 3,
Well, there's an H over here, I guess. Yeah, yes, the H is over 3, and how many T?
1.
So with the polyatomic ions, you can break them up. So the OH in number 7, you can count the O and H separately. Just remember to distribute the 2. So if it's OH in parentheses with the 2 on the outside, that's 2 O's, 2 H's.
Try to make that.
That
I
means
mean,
that
I
one has
see, I can make it work.
Let's see, number 9 is almost right. Oh, when you put that 2 there, that changes the NH2, but that also changes the O and the H.
I'm seeing 11 and 12.
Oh, you can keep it split up, I guess, that's fine. You have 2 H's and 2 H's, but the O's, I think you forgot to update the O's. Because there's a 2 in front, so the O.
Alright, what is it?
Yeah, and then you're gonna have to do some stuff with that.
And 12.
No, it looks harder than the.
Isn't this fun?
Yeah.
This is not.
I'm trying to remember. What's up, Dan? What'd you get?
I like,
Blank. Blank.
Alright, you give me the
I don't even know.
I'm just gonna 3.
This class gets math.
Change the H's back to
Dimensional analysis, my brain shuts down.
But then you got it. I believe in you.
Yeah, after I
Okay,
had to
yeah,
come
we don't have
home.
6 yet. We do have 6 on
So
the
then the hydrogen,
side.
we'll worry about that. Really?
Let's erase that 3.
Is it
We're
four?
going a little too far. I'll give you a hint.
Hold on.
You give me one coefficient, I can do it. You
Please.
give me
All
one, I
right.
can't.
You guys, number 7, I'm going to show you how I approach it. Good question on number 7.
Oh wait, I got an idea.
I don't got an idea.
I got an idea.
I'm approaching a.
All right. For number 6, actually, let me do number 6 real quick. You're going to end up aiming for 10 on either side. So you'll end up needing a 4 here, right? Okay. So number 6 is 4, 5, 2, right? Okay. So number 6 was very similar to number 5, okay, in that, like, there was nothing times 2 that would give you 5 oxygens. So you had to aim for 10 oxygens on both sides. Because the least common multiple of 2 and 5 is 10. Okay, number 7 is tricky for a couple reasons. There's parentheses, which make it tricky. And there's hydrogen in 2 different spots on the reacted side, which also makes it tricky. So I'm going to show you something that'll help with this type of thing. Okay, so count the O and the H separately. Even though they're in parentheses here, they're not in parentheses over here, so it's easier to count them as separate entities. So PbOHCl, PbOHCl. Okay, so the Pb is 1. The OH has a 2 on the outside, so that means there's 2 O's and 2 H's. Okay. The thing is, there's also an H over here. So I like to write that as like maybe +1. Sometimes that's more helpful than just writing 3. Because when you see 3, you forget that it's coming from 2 different spots. But this reminds you that it's 3 total, but it's coming from 2 spots. And then the Cl is just 1. Okay, on this side we got 1 Pb, 1 O, 2 H's, 2 Cl's. What you can see immediately, what's going to be the problem here? Which element is going to be your headache? The hydrogen, right? When you have this issue where on this side the hydrogen total has to be even. You see how no matter what I put here, the hydrogen total is going to be even? No matter what I put here, the hydrogen on this side is going to be even. That means on this side, do something so that the hydrogen total is even. What should I put here to make sure that the hydrogen total is even? A 2. If I knock that up to a 2, or any multiple of 2 thereafter, I know that the hydrogen is going to be even on this side. So by putting a 2 there, getting this total up to 4, that kind of sets you off on the right path, okay? So I'm going to stop talking there, but I think once you have the 2 in front of the HCl, that'll get you on the right track, okay? So solve like that even odd problem. When you know that there's like an odd number on one side, bump that up to an even number so that it'll match the even number on the other side. Another thing that I'm seeing, like for example, number 8, the answer is blank 3, or 1, 3, 1, 3. What I was noticing is some people had 2, 6, 2, 6. It's still balanced, but this ratio can be reduced back down. So if you wrote something like 2, 6, 2, 6 on a test and it was balanced, I give you half credit. But if it's a ratio like this that you can reduce down to 1, 3, 1, 3, you need to reduce it back down. It's fine to get a little carried away with the balancing that happens, but always reduce it back down in the end, and you'll see that it's still balanced with 1, 3, 1, 3. Okay, so if your coefficients can be reduced back down, reduce them back down. I'll still give you half credit because it's balanced technically, but reduce it back down. Move this one up, because this one, you see how this one as it is making an odd number of bases, whereas this side is always going to have even number of bases. So take care of the odd one by putting a 2 in front. You ensure that this side is always even. That makes sense. So that's why I knew to target that one rather than that one, because that one was the one making an odd number. We know we need to even number. Right. Looking good. Number 12 is probably the toughest one. Don't feel bad if number 12's taken a long time. It's supposed to. Yeah. Oh yeah, you got it. Good. I mean, it's number 9. I feel like 7 and 9 are harder than 12.
I skipped 7 and 9 and did
Oh, okay.
these ones.
I was getting the 12 right.
Yeah.
So I can't do it first.
1, 5,
I'm trying to think of a hint. Oh, number 9, same hint. You guys, for number 9,
Sometimes I did it wrong too.
my hint for number 9 is the same as my hint for number 7. You see how the hydrogens in number 9, the hydrogens here are always even. Are the hydrogens on this side even? Which one's making it odd, the NaOH or the H2? See how that's making an odd number, but you know it has to be even? What should I put in front of here? Put a 2 there to make the having a 2 or a multiple of 2 will make sure that you have an even number of hydrogens. So that'll start you off on the right path. All right, so finish this tonight if you didn't, and we'll go over it tomorrow in class.